today we will be talking about a new concept, but I'm not going to tell you exactly what that concept is yet. I wanted to hit on the fact that we already know that any kind of object or item or any kind of matter can be classified or categorized. And we know this because we have groups in our classroom. We have different desks. We have the red group and the blue group and the yellow group and the green group. And we always line up in different types of categories. I'll say anybody that's wearing tennis shoes line up, anybody that's wearing a jacket, or anyone that's wearing shorts or pants, or there's a bunch of different kinds of ways that I can classify and categorize our class, and that goes for any object or any type of matter in the world. We can classify and organize all sorts of things. So that's what we're going to be talking about today. Something along those lines of classifying and how we organize different matter. So if you know a way or a characteristic of something that you would classify and observe about an object, raise your hand and share that with me and the rest of your class. So our observable property, for example, was the word soft. We can describe something as being soft. This is an observable property of matter. We know this because it is a property that can be observed with our five senses. We use our five senses to observe different types of matter, and that's how we learn their properties. So, for example, we have this ball here. I'm going to use my five senses that I have to observe the ball and find its observable properties. A property is a characteristic, so let's just remember that when we're observing. So I'm observing this ball by using my five senses. So first I'm going to use my eyes. When I use my eyes, I can see that this ball is pink. The ball is round. The ball is, if I just look at it and don't feel it, it's spiky. It looks like it has little spikes on it. Now when I use my hands to feel it, I'm going to squish it, and I can see that it is squishy, it is stretchy. I can stretch these little guys here. I can feel that it's kind of bumpy when I rub my hand along it. I can smell this. I can smell that it smells like rubber, which that explains why it's stretchy. Rubber is usually stretchy. I'm not going to taste it because I don't think it's anything that's edible, but I can hear it. If I rub my hand along it, I can hear the way that the little bristles that it has, when they pop, I can hear that, so I know that it's definitely making noises from being able to be moved. It's definitely not hard. I can move these. So these are all observable properties of this ball. So let's look at something else. I have this little box here with Mickey and Minnie on it. I'm going to see if this box has observable properties like the ball does, which it will have observable properties, but they don't have to be the same as the ball. In fact, they could all be different. So I'm going to use my eyes first to observe this box. I can see that it's definitely not round, and we know that it's not round because it doesn't have curved surfaces like the ball does, but it has flat, smooth surfaces. I can feel that with my hand, and I can see it with my eyes. I don't think smelling it would really help me, so we'll skip that one. And I don't think tasting the box is going to help me in any way either. So I can hear it if I tap my finger on it, which tells me that it sounds like it's hard because I hear like a little echo. It's like, because it's tin, so it's very hard and strong. As I use my hands to try to squish it, like with the ball, it's not very squishy, it's very hard. So those are our observable properties of this box that I have here. Now, a common misconception is that if you were to have something that is squishy or stretchy, that once you stretch it or once you break it, that changes its identity completely. So let me tell you what I mean here. So I have this rubber band here. I'm going to stretch it as far as I can, and let's say I don't know if I'm strong enough, but if I break this rubber band, because it's very stretchy, it's breakable. That's an observable property of this rubber band. Now, if I break it, does that change the identity of the rubber band? No, it doesn't. It's still a rubber band. I can put it in water, I can stretch it and break it, I can do almost anything that I want to it, and it doesn't change the identity of the rubber band. So it being stretchy and breakable is an observable property, but an observable property is only one that does not change the identity of the matter. So if it's something, if you have matter and whatever happens to it, if it changes to something else afterwards, completely something else, it's not the same anymore chemically, then it's no longer the same identity. It is something different. So there we go. So also, another misconception that's along those lines is water and freezing and boiling points. So if you have water in liquid form, it's going to take the shape of whatever container that it's in. So that would be an observable property, the shape that it is. If it's in a spherical bowl, then it's going to be circular because it's water. It's going to take whatever kind of shape that you give it, whatever kind of container that it's in. So if you freeze it, it now becomes ice. Now, it chemically is still the same. It's still H2O. It's still water. It's just water in a different form. It's frozen. That freezing point is an observable property because we can see and we can observe that it is now frozen. The same thing goes for water when it turns into water vapor. When it hits its boiling point, once it starts boiling, it starts to evaporate and turn into water vapor. So these freezing and boiling points are misconceptions because a lot of students think that once water goes to ice, that ice is not water anymore, but it is still the same thing chemically. It has not changed its identity, just its observable property. It is now hard and frozen, whereas the water was liquid and it can take any kind of shape depending on what you put it in. So those are some common misconceptions about observable properties with matter.